all these functions. We need to be able to transfer it. We need to be able to get the balance of it, etc. And again, if you want to check out some of the improvements that are still ERC20 compatible, like the ERC677 or the ERC777, you definitely go check those out and build one of those instead. So let's create a new folder and get started. We're going to create our new Brownie file, of course, with Brownie init. It's going to start up our repository and start up everything that we are going to work with here. We can kind of actually just jump in and start right with our contracts. So let's create a new file and we'll call it our token.sol. And this is where we're going to add all of our token code. Now, since this is an EIP, right, all this is a smart contract. So what we could do is we could grab all these functions, copy and paste them in here one at a time, grab the name, grab the symbol, grab the decimals, and then, code all these up, be like, all right, this does some stuff, blah, blah, blah. Or we could do it the much easier way, right? Since we're engineers, we don't always want to reinvent the wheel. So once again, our friends at OpenZeppelin have some amazing contract packages for actually building our own ERC20 token. So we can go right to the OpenZeppelin documentation. I'm working on the 4x version, but again, it doesn't matter the version that you use so long as in our config file, we add the version that we're going to use, which again, we've already gone over. So let's go over to their ERC20 documentation. And this is the entirety of the code that is needed to make an ERC20. So we can just go ahead and even copy this, paste it in here, and boom, we have some ERC20 code in here. Let's actually just change the name of everything in here though. So we're gonna call this our token.sol. We have this SPDX license identifier, MIT, great. We're gonna be using Solidity version 0.8, which I know I've done a lot of this code actually in 0.6, but I highly recommend working with 0.8 because it has a lot of really fantastic improvements to Solidity. You'll notice this is our first dive into using a different version of Solidity here. You'll notice that most of the syntax is exactly the same. There are, like I said, a couple of nice improvements with 0.8. The main one being you no longer have to use those safe math functions that we talked about before. But then we're going to go ahead and import OpenZeppelin contracts token ERC20.sol. Now, of course, since we're importing OpenZeppelin, we're importing this package. We got to add this to our Brownie config.yaml. And before we even get started, you technically have all the tools that you need to code and deploy your own ERC20 token. Now, I'm actually going to challenge you to go ahead and try to start a Brownie project, create your own token using OpenZeppelin packages, and then deploy it on a testnet. I'm going to show you how to do all of it here anyways, but challenging yourself and trying to do things your own and exploring is really one of the fastest ways to learn and grow in this space. Did you give it a shot? No, really, pause it now and give it a try. All right, welcome back. Now we'll go through it and we'll do it together. Of course, we need to add these dependencies. OpenZeppelin contracts. Let's do their version 4. So let's even go to GitHub, OpenZeppelin. And we'll do 4.2.0, which was released yesterday at this time, which is great. 4.2.0. And of course, again, compiler. We'll have Sulk. Oops. Remappings. We'll add at OpenZeppelin equals this. And then we're going to go ahead and save. Now we can use this at OpenZeppelin and it'll refer to the OpenZeppelin contracts here. So great, now we can go ahead and import these. Let's change the contract name to our token. We're going to inherit this ERC20.sol from OpenZeppelin. We can even go ahead to OpenZeppelin contracts GitHub and we can even see what this ERC20 looks like. So we can go to their contracts, down to token, ERC20, ERC20.sol. And this is their initiation of an ERC20, which has all these functions like name, symbol, decimals, total supply, etc. In our constructor, we're going to add an initial supply, which is going to be in way, of course, so the initial supply of that token. And we're going to use the constructor of the erc20.sol, which again, we can go ahead and check in the code here, and we can see the constructor uses a name and a symbol. So we have a name, we'll call it our token, and the symbol we'll do OT. And boom, that is literally all we need for our token here. I told you this was going to be a much faster project. Now, for scripts, all we have to do is create a new file. We'll add a one deploy token.sol, and we'll also add a helpful scripts.py. Excuse me, this deploy token.py, excuse me. We'll just quickly add a get account function. We'll say def get account. And you can go ahead and just copy paste from the last one. And if you want, you can actually just copy paste from our last helpful scripts because it's pretty much going to be exactly the same. So that we have all these wonderful ifs statements so that we can deploy from really anything that we want. Now, in our deployment token script, we'll do from Brownie import our token, and then from scripts dot helpful scripts import get account, and just to make sure, let's add an init.py in here, just to make sure that our scripts can actually import. So since we know that we need an initial supply here, let's go ahead and do initial supply equals, and then we can do whatever we want here. If we want to make it a little bit more readable, we'll also do from web3 import web3, and we can do web3.toWay, and we'll say 1000 is the initial supply, and this is in Ether. So our initial supply is going to be 1000 Ether. Then we just add our main function. We do account equals get account. We do our token equals our token dot deploy. We just add as a parameter this initial supply. We'll do from account, and then we'll do print our token dot name, and that's the whole function. Now, of course, if you don't have your environment variable set, we're going to add our .env file. This is where we can add our private key, our Web3 Infura project ID, and then if we want, our Etherscan token. I'm going to skip doing this for now because my environment variables are already set. And then, last but not least, we'll add .env. So private key equals OX blah blah blah. Web3 Infura project ID equals blah blah blah. Etherscan token equals blah blah blah. And perfect. Now, if we want to actually deploy this to a testnet, all we have to do, go into our config, we'll add wallets, from key, we'll add our environment variable private key. Now, Brownie knows where to grab this from because we've defined it in our helpful scripts. What I could do now, so Brownie runs scripts, deploy token.py, and we can go ahead and see that our token is printed out. We can see that we have this token deployed on our local ganache. We can see our token here, and this is great. Now I can go ahead and run this again. Network Rinkeby. Now if I grab this address, go to the Rinkeby Etherscan, pop it in. After a quick refresh, I can now see that my contract has indeed been added. And Etherscan even picks up that it's a token. Now, what we could do is grab this contract address, go to Assets, add it in our MetaMask here. Next, add tokens, and you'll see we are the proud owners of 1,000 our tokens. Now, something else that you might want to do is add this to a liquidity pool, or add this to a place where you can actually go ahead and sell it and put it on the market. You can do something like that as easily as just popping onto Uniswap, going to pool, hitting more, create a pool, and then adding our token in here. We'd have to manage the token list and be sure to add the token in here, but we could go ahead and add a token, create our own pool, and automatically put it on Uniswap. And that's how easy it is to actually sell it on one of these pools. But all right, so this was probably our easiest project of the course, but it really shows how far you've come along. Everything here. that we know a little bit more about DeFi and why it's such an amazing, amazing technology that only works in the blockchain world, let's look at this site DeFi Pulse. Or if you want to look at another one, there's another fantastic one out there called DeFi Llama, which also shows a lot of these different protocols in here. So DeFi Pulse is an application that shows some of the top DeFi projects based on how much total asset is locked into each protocol. Aave, which currently is the #1 ranked DeFi application with 9.32 billion in assets under management in terms of USD. Then we have some fantastic ones like Curve, Compound, Maker, Instadep, etc. Now we're going to be looking at 2 of these protocols in particular. The first one, of course, being Aave. The second one is going to be a type of what's called a decentralized exchange. To get started with Aave, we're going to go to testnet.aave.com/dashboard, and it'll bring us to a screen that looks something like this with please connect your wallet, and everything will be pretty empty. Paraswap is what's known as a DEX, or a decentralized exchange. It allows us to trade tokens incredibly easy on the blockchain. Now, there's not a whole lot of testnet DEXs that actually work, so we're just going to look at them and simulate as if we were working on them. For example, if I wanted to trade 1 ETH for some USDT, or maybe some wrapped Bitcoin, or some DAI, or some Aave, or Link, or really any token that we wanted, all we would need to do is connect our wallet here, and a swap button would show up, and we would go ahead and hit swap. Some other really powerful, these DEXs and really popular ones are going to be Curve Finance, Uniswap, and it's a really, really easy way to go ahead and swap your tokens for one another, depending on what you're looking to do. Aave is incredibly powerful, and it's going to be one that we're going to be working a lot with because it has pretty much all the fundamentals of working with the DeFi protocol that we're looking for. And it has a testnet that we can go ahead and test and simulate actually working with some of these protocols. So we're going to first work with the UI, or the user interface, and then we're going to do everything here programmatically. First things first, if you don't already have it, make sure you have some testnet Ethereum at least. And again, you can get some testnet Ethereum from looking at the link token contracts and going to Coven. This one, indeed, the testnet of Aave right now is only on Coven. So we're going to go ahead here. We're going to copy our address, paste it in. I'm not a robot. Send me 0.1 test ETH. Remember, use this link token contracts page because this is going to have the most up-to-date faucets here. Once we see some ETH in our Coven testnet here, we can go back to Aave. So whereas Paraswap allows you to simply swap between assets and do a lot of buying and selling of tokens, Aave is a lending and borrowing application. So we can actually put down a token as collateral, and we can borrow, and we can generate some yield from interacting with this protocol. Borrowing and lending is a critical piece to doing any type of really interesting financial applications or financial instruments, such as short selling, being exposed to more assets, etc. You can also gain some percentage back. If you look at APY, it'll tell you how much percentage over a year you'll actually get in returns from staking or depositing an asset. So here's what we're going to go ahead and do. We're going to connect to the application using MetaMask, and you'll see on the deposit tab here, we'll see our balance be 0.1 ETH because that's how much I currently have in my wallet right now. What we can now do is click on ETH here, click this max button to deposit some Ethereum. We'll hit continue, and a little dashboard will pop up asking us, okay, would you like to deposit? Clicking this deposit button will actually have us deposit right onto the Aave contract on the Coven testnet. Make sure once you hit deposit here that you're actually on a testnet here. It looks like I actually have some insufficient funds, so I'm actually going to go borrow a little bit more from the faucet here. Grab a little bit more from the faucet here. We're going to come back. We're actually going to go back. We're going to refresh, and now it says I have 0.1. We're going to deposit 0.1, continue, deposit, and MetaMask is going to pop up saying, hey, are you sure you want to do this? Right? We can check our data. We can grab this address even if we want, pop it onto coven.etherscan, paste it in here. We can even double check to make sure that this is indeed the right contract that we want. Funnily enough, you'll see that this is the WETH gateway. When we deposit our Coven ETH, it actually gets transferred into an ERC20 version of our Ethereum, and then it'll go ahead and deposit it into the Aave contract. So we're going to hit confirm, Now we're going to get this pending here. We have a link to the Explorer.